Okay, in this video, again, make sure you don't need to watch this video unless your course involves trigonometric functions. But I'm going to show you here how to find derivatives of inverse trig functions. We've already discussed how to find derivatives of trig functions, but here we're going to work with inverse trig functions. So if you need to, go ahead and review some notes on what inverse trig functions are, but I'm going to assume that you know what they are, and I'm just going to show you how to find their derivatives. Okay, so the derivative of the arc sine function of u, where u is a function of x, is actually u prime over the square root of 1 minus u squared. And you can find these formulas in any calculus book. The derivative of arc cosine of u is minus u prime over the square root of 1 minus u squared. The derivative of arc tangent u is u prime over 1 plus u squared. The derivative of arc cosecant u is minus u prime over the absolute value of u times the square root of u squared minus 1. The derivative of arc secant u is u prime over the absolute value of u times the square root of u squared minus 1. And then finally, the derivative of arc cotangent u is minus u prime over 1 plus u squared. And so in each of these definitions, u is some function of x. So I'm going to start out with a simple one here. I'm going to start out with finding the arc sine, the derivative of the arc sine of 2x. Now in this one, looks like my computer's running down, so let me pause it and plug it in. So in this one, I would use the formula for arc sine of u, and where u would be 2x. So if you look at the formula, it says in the in the numerator, you would have u prime, which would just be the derivative of 2x. So I would have 2 in the numerator. And then in the denominator, I would have the square root of 1 minus u squared. So in the denominator, I'd have square root of 1 minus 2x quantity squared. So go ahead and put the 2 in the numerator and then square the 2x, and you get 2 over the square root of 1 minus 4x squared. So that would be the derivative. That would be the solution for the derivative of that function. Now, one thing I want to remind you is these functions could be written another way. So let me show you another way to write arc sine of 2x, just to make sure you don't flip out if you see it written another way. So another way to write the arc sine function is to write it with a little -1 exponent here. But if you see that, remember that's not the reciprocal of your sine function. That's actually a notation for the arc sine of 2x. So I went ahead and used the arc concept here on all of my examples. But you might see these functions written with a -1 exponent as well. Okay, going on to the next example, we're going to look at what about the arc tangent of x squared. Well, in this one, we would use the formula for arc tangent of u, where u equals x squared. Okay, so let's find the formula for arc tangent. Looks like that would be right here. And so we would have u prime in the numerator, so that would just be the derivative of x squared, which is 2x. I could have just put it up here, but that's 2x. And then over 1 plus u squared. So that's going to be 1 plus x squared quantity squared. So put it all together and you get 2x in the numerator and 1 plus x to the 4th in the denominator. And then that's your derivative for the arctan of x squared. And then the last one here is we're looking for the arc secant, the derivative of arc secant of natural log of x. So we have y equals arc secant of natural log of x, and of course in this one my u is simply natural log of x. Okay, so anyway, so what I would do there, I look up for the formula. Where is it? Here it is. So here's the formula for arcsecant of u. So for that, I would have u prime, okay, in the numerator, which is just 1 over x. So I'd have 1 over x in the numerator, and then over the absolute value of u. So that would mean I would have to have the absolute value of natural log of x, and then multiplied by the square root of u squared. So that would be the square root of natural log of x quantity squared minus 1. Now, if you put 1 over x in the numerator, that would be the same as putting 1 in the numerator and x in the denominator. So I'll just go ahead and put the x there, and then I'll bring down the rest of it, the absolute value of natural log of x times the square root of natural log of x quantity squared minus 1. And so there's your derivative for that function. So basically it's just a matter of applying these derivative rules to each of these arc-trig functions. And I didn't do one for all 6 of them, but if you do need to find the derivative of other arc functions like arc cotangent or arc cosecant, then you just apply the rules similar to how I applied the rules for these 3. And that's pretty much it on the derivatives of inverse trig functions. And so the next video I'll show you how to find derivatives involving hyperbolic functions, and whether you need derivatives for hyperbolic functions, you'll have to decide if it's important for you to look at the next video. But the next video will be derivatives for the hyperbolic functions.